In this video, I want to have a look at inverse variation. So if two variables vary inversely, then that means that an increase in one variable is going to mean a decrease in the other. So as one thing increases, it means the other variable is decreasing. So when we graph an inverse relationship, it actually ends up being part of a hyperbola. So if we had two sets of axes here, as one variable is increasing, so as we move this way along the x-axis, the other variable is going to decrease. So that means it's going to start up here and it's going to decrease as one increases. So as this variable is increasing, this one is decreasing. So what that means is that if y varies inversely with x, we get an equation that looks like this. So y equals k over x, where k is what's called the constant of proportionality. So that's just a number, and in each situation we'll be asked to figure out what that number is. So let's run through an example. It says the time taken to drive from Sydney to Newcastle varies inversely with the average speed of the car. So that means the faster you're driving, on average, the faster you're going to, the less time it's going to take to get there. Then it tells us that the trip takes 2 hours if the average speed is 80 kilometers per hour. So the first part of the question, pretty much as always, is write a variation equation relating the time taken to the average speed. So because it relates inversely, we know it's going to be the time taken is equal to k, our constant of proportionality, over the average speed. So I've just said that time taken is t and the average speed is s, but you can use whatever letters you like. So we know it's going to satisfy this relationship, but we need to figure out the value of k. So to do that, we're going to substitute in the information that we know. So we know it takes 2 hours when the average speed is 80 kilometers. So that means 2 hours, k over 80. And then to get k on its own, we'd have to times both sides by 80, and we'd end up with k equals 160. So that means our variation equation is t equals 160 over s. So that's part A finished. Part B says how much longer will the trip take if the average speed is 70 kilometers. So we're going to substitute that 70 into this equation as our speed, and we can make that calculation to figure out what t is. So t is going to be 160 over 70, which is going to give us 2.285, and the number keeps going. If you press the degrees, minutes, seconds button on your calculator, it'll actually convert it into degrees being the hours, minutes being the minutes, and seconds being the seconds. So that means it would take us 2 hours and about 17 minutes. But the question doesn't just ask how long it will take, it says how much longer would the trip take. So before it took us 2 hours, and now it's taking us 2 hours and 17 minutes. So we'll write therefore 17 minutes longer. All right, one last part, part C, says on a public holiday, the trip took 2 hours and 45 minutes. What was the average speed of the trip? So you can use the degrees, minutes, seconds button on your calculator to put this in as 2 hours and 45 minutes. Or you can look at that and say, okay, well that's 2 3/4 of an hour. So we could write that as 2.75. So I'm going to do that. I'm going to write 2.75 hours. We had our 160 over our average speed. So we don't like that unknown being in the denominator, so we'll multiply both sides by s. So we'll have s times 2.75 is equal to 160. And then to get the s on its own, we're going to divide by 2.75. So 160 divided by 2.75. And we'll end up, if we round to the nearest whole number, with 58 kilometers per hour. So that's just one example of a problem involving inverse variation.